Good morning, everybody. You probably had a guess while we were doing all this stuff with proportions and things like that that we were most likely going to move on to confidence intervals for a mean next. So if that was the case, you are right. So here's the main deal. We still have conditions for confidence intervals for mean. So when we're taking an X bar and we're trying to estimate the true mean of a population, okay? We still have random. That has not changed. So the only thing that's different is we use that same kind of large counts rule where you say as long as the sample size is greater than or equal to 30, we're okay. So here's a little note down here. Don't forget that for proportion, that calculation is this guy right here, the NP and the N1 minus P. Calculating the true mean is just, is it greater than or equal to 30? Yes or no, and move on. So that's the main difference between proportion and mean, or the first main difference is that calculation. Your state is going to be basically the same thing as what we did before. So your plan is just, instead of checking these conditions like we did for proportion, you check this guy with random, okay? All right, so for example, here's a problem. To estimate the average GPA of all students at her high school, Kiana randomly selected 30 students from the school. Are the conditions met for calculating a confidence interval? So remember, she's picking 30 students. She's going to find their average GPA, which is going to be like X bar, and she's going to use that to make a confidence interval for what is the actual true mean of the GPAs of everyone at her school. So you ask yourself, is it random? Yes, it actually says she randomly selected, so we're good. And is the other condition met? Yep, 30 is greater than or equal to 30, we're good. So it's kind of nice because when you're finding confidence intervals for mean, those conditions actually go a lot faster, in my opinion. All right, so in our lesson about proportion confidence intervals, we came up with this guy. Okay, this was basically our point estimate plus or minus our margin of error. And the way we got that is we used p hat plus or minus, and we used that z critical value multiplied by the standard deviation, okay? So in general terms, it's what's the statistic that you got, okay? So in this case, if before we were using p hat, my guess is the statistic we're going to use is x bar now, okay? Critical value. So we're going to talk about that because that's going to change a little bit with mean, okay? But you still need a critical value so you know whether you're using 90%, 95%, so on. And then this was the standard deviation. They call it standard error, but it's kind of the same idea. And so in this case, we're going to use the standard deviation divided by the square root of n. Now, having said that, if we don't know the true mean, we don't know the true standard deviation either in this sigma. So usually what we do is we use s of x over square root of n, because we do have the standard deviation for our data, okay? That's not a big difference. Don't forget, like if you're taking AP stats next year, there's a big difference there, but if not, don't worry about that too much as to which one we use. Here's the only downside, you guys. There was an activity I was going to do with you guys that really kind of clarified this next step. I was trying to wrap my head around how to do it for remote learning, and there's just not a possibility. So I think you're just going to have to bear with me and just trust that it's weird. Here's what I mean by that. When we're doing mean, we actually can't use a z critical value like we did before. So those 3 z critical values, they'll still work for confidence intervals for proportions, but it doesn't actually estimate confidence intervals for mean as well. So what we do in this case, I'm going to switch my colors here, is we use what's called a t critical value. There's a whole reason behind it. There's an exploration we were going to do. It's just not something I feel comfortable trying to explain on remote learning. I don't think it's going to work. So I think you guys just have to give me a little bit of wiggle room and just trust that t is what you use for mean, okay? So how do you find the t critical value? You use a table and find the correct confidence level at the bottom of the table. I have attached this table to this lesson. So you'll see it on Google Classroom. You'll see the link to the video. Then you'll see the PDF for the t table right underneath it. Okay, so just so you know. On the left side of the table, find the correct number of degrees of freedom. Okay, and basically all that is what's your sample size minus 1. Okay, so let's say our sample size is 48 students. I'd say 48 minus 1, and my degrees of freedom are 47. I'll show you what that looks like on the table in just a second. In the body of the table, find the value of that t critical value that corresponds to the confidence level and the degrees of freedom we just calculated. The only difference is if the correct degrees of freedom isn't listed, use the greatest number available that's still less than that, okay? So for example, let's say I'm doing a 95% confidence interval and I'm using that degrees of freedom of 47. If you look at your table, it'll look something like this, okay? So actually in this one, so here's a great example. There was an activity that I kind of cut out of the notes, but what if we were calculating 99% confidence intervals? Well, if we're using 99%, that means there's 99% in the middle, 0.5% on this side. Well, 0.5% is 0.005 as a decimal, right? Notice how they're looking on the table at a confidence level of 0.005. So that's the tail probability, or you can literally on the bottom of the table, it says 99%. So if that's easier for you, awesome, use that. It lets you know to use that column. Then if n is 4, when you plug it into your degrees of freedom, that means we're using degrees of freedom is 3. And so that's why you'll see these purple tabs. So we would use a t critical value of 5.841. Okay. The only thing I want you to look at is if you look at your table that I have attached, for example, there is no degrees of freedom of 47. Okay, if I remember correctly, because I don't have it pulled up in front of me, I think it jumps right from 40 to 49 or maybe 40 to 50, something like that. So you would actually want to use 40 on that table. You would want to use the greatest degrees of freedom available that's less than what you calculated if it's not exactly on that table, okay? All right, so what I would like you to do is just practice using the table, pull it up on your phone or on a different screen, you kind of toggle back and forth if you need to, and find what would be the t critical value for both A and B below. When you're ready to see the answer, go ahead and unpause your video. All right, so for A, okay, for that t critical value, your degrees of freedom is going to be 11 because you've got a sample size of 12. So 12 minus 1 gives you 11. And if you find 95% confidence on the bottom, that should go with a tail probability up on the top of 0.025. So if you follow those together, that's where the 2.201 comes from. Let me see if I think I pulled it up here. Yeah, perfect. So my degrees of freedom was 11. Confidence interval was 95, so if I follow 95 up, degrees of freedom 11, you'll see that 2.201 right in the middle, okay? It's kind of hard. I can't draw on PDFs on here, so if you're having a hard time with this, stop by and see me for office hours, and I can show you with my finger exactly where I'm getting these values from, okay? If you do the same thing for letter B, okay, confidence interval, your degrees of freedom is 47. You want 90% confidence interval. So see, notice how for degrees of freedom, it jumps right from 40 to 50. So if we got degrees of freedom of 47, I want to use 40. Don't use 50 because you're going to want to. You're going to say, oh, well, 50 is closer to 47. I get that. Use the smallest, or I guess the greatest value of degrees of freedom you can use that is still smaller than the number you found if it's not listed. Okay, so pretty much anything over 30 kind of gets screwed up there. Okay. All right. Okay, here are my answers as well to kind of help you out with the visual part of it, okay? So notice how confidence level, you can either use the 95% or the tail probability. You'll give you the same column, and our degrees of freedom were 11. That's where that value came from. Same thing down here, 90% or a tail probability of 0.05. That's where that number came from, okay? So again, if you're still getting stuck with that, stop in for office hours. I'll help you out and clarify it a little bit more. All right, so this slide is basically saying everything that we used to know. So what I want to draw your attention to, just to kind of skip around a little bit, this was our formula for confidence intervals for proportion, right? What's your p-hat? That's your point estimate, plus or minus the z critical value, all multiplied by the standard deviation using that formula. Mean is doing the exact same thing. Your point estimate is x bar, plus or minus, now your critical value, you're using t critical value instead of z. That's a big difference there, okay? And you're still multiplying by the standard deviation, which back in Unit 6, we knew to find the standard deviation using the sample standard deviation divided by the square root of n. So basically right here is the big, there's a lot written on here. This is the big takeaway, okay, of, okay, depending on whether I'm working with a mean or a proportion, that's what I'm using. It'll be real obvious in the questions, you guys. It'll say with a sample mean of, or it'll say with a sample proportion of, and as soon as you see the word mean or the word proportion, you go, oh, this is the one I want to use. Okay, oh, it's a mean, so I want to use the t-table. Oh, it's a proportion, I want to use my z-table or use my graphing calculator with those steps I showed you guys yesterday. So here's a good example problem. I have the answers all listed out for you. Notice how they give you the X bar. That's your hint that, oh, okay, it's a mean. And they want you to calculate 99% confidence. Well, 3.19 is my point estimate, okay? With 99% confidence and a sample of 30, we're using 30 minus 1, or degrees of freedom is 29. Okay, now technically I probably should have checked for my conditions, okay, but it does say we verified that the conditions were already met. So yay, I don't have to worry about it, okay? So you don't have to check the conditions unless they don't say that. So if you use degrees of freedom of 29 and 99% confidence on the bottom of your t-table, that's where I got this number from, okay? The sample standard deviation is 0.72, all divided by the square root of n. And I start doing my calculations, and that's where I get my interval. Now, technically, I should write my answer as a full sentence. I should say, we are 99% confident that the true mean, or the true mean GPA for all students at Kiana School lies on the interval 3.19 plus or minus 0.362. Okay, so technically I should write it in a sentence, but since we're still kind of just learning, that's okay. So don't forget, you guys, yesterday I posted the homework number 4. You now can do the second 2 pages of that homework assignment and then submit it tonight by midnight. Remember, just take a picture of it. Also, don't forget, if you print out the homework as a Word document, not all of the math script shows up. So if you use the answer key to kind of fill in some of the math pieces where it looks blank, that can help you. If you have Microsoft Word, it should show up just fine. But if you only have like Google Docs or whatever, it might show up a little weird. So I apologize for that. I've tried to find a workaround and doesn't seem like I can find one that's easy that works really well. So again, stop by, see me for office hours if you have questions. It's a lot of information, but mostly it's just a ton of formulas. And if you can keep track which one's which, then you're set. All right, let me know if you have questions, guys.